Welcome to solverfy.
We have to solve the problem regarding the motion of the rocket. At the initial moment of time, the rocket is launched with a initial velocity v0, and then it immediately accelerates by the engine. So it accelerates along the same vector, which is angle alpha with the horizon. And so during the initial time of motion, it reaches some velocity of v1 under the acceleration of a. And then the engine stops working, and the rocket follows the parabolic motion. So here we have to find total height of the flight, the displacement, the range, and the total time of the flight. Let's do this. But first of all, let's split the motion of the rocket into several parts. So the first part is from 0 to 1, and then from 1 to 2. Let's do this. So the period from 0 to 1 is a motion under constant acceleration, and the velocity of the rocket at time 1 equals to the initial velocity of the rocket plus a delta t. So a has the same direction as the velocity, so therefore we just multiply it by time. So therefore v1 equals to v0, 95 meters per second plus 3.17 seconds times 25.5 meters per second squared. So let's calculate it. It equals to 175.8 meters per second. So let's leave all the decimals for now, and we will account for the number of decimals later. So now let's calculate the height at position 1. So basically let's calculate h1 and L1, because we'll need these positions later. So the overall displacement of the rocket during this initial launching can be calculated as S, delta S, and delta S equals to V1 squared minus V0 squared divided by 2A, which is 175.8 meters per second squared minus 95 meters per second squared divided by 2 times 25.5 meters per second squared. Let's calculate this number. It equals to 429.3 meters. So that's the total displacement, and from this triangle we can find L1 as delta S times cosine alpha. Or 429.3 meters times cosine of 46.2 degrees. It equals to 197 0.1 meter. Or we can, okay, let's leave it as 297 meters. And as h1 equals to delta s times sine alpha, which is 429. Or actually, yeah, let's leave one decimal here and we'll round it later. Okay, now we've calculated values of h1 and l1. So we don't need anything from this period anymore, from this moment of from this motion anymore, from 0 to 1. Now we can focus on the movement from 1 to 2. So here acceleration equals to g only, which is in y axis, and the initial velocity is v1, which is 175.8 meters per second, and angle is the same. The angle is 46.2 degrees. And also we know h1, which is 309.9 meters, and l1, which is 297.1 meter. Okay, now let's write down the equation for the coordinate y as a function of time. Here for 1 and 2, we will introduce time scale t prime, which is equals to 0 at 0.1. So therefore, y as a function of t prime equals to h1 plus v1 times sine alpha t prime minus gt prime squared over 2. And the x coordinate as a function of t prime equals to L1 plus V0 cosine alpha t prime. Yeah, because there are no x's in the horizontal direction. Meanwhile, Vy as a vertical component of the velocity as a function of t prime equals to V1 sine alpha t minus g t prime. So now we can find the moment when h maximum is achieved. So let's do this. It's achieved when Vy as a function of t prime is 0. So therefore, t prime equals to V1 sine alpha over g, or it equals to 175.8. Oh, sorry, here is a typo, it's meters per second. Meters per second times sine of 46.2 degree divided by 10 meters per second squared. Let's calculate it. It equals to 12.69 seconds. 12.69 seconds. Okay, this is the time which is needed to reach H maximum. So therefore, H maximum equals to H1 plus V1 sine alpha T prime H maximum minus GT prime H maximum squared over 2. Now we can calculate H maximum. It equals to H1, which is 309.9 meters plus 175.8 meters per second times sine of 46.2 degree times 12.69 seconds minus 5 meters per second squared times 12.69 seconds squared. Now we can calculate this number. It equals to 1,115 meters. So that's H maximum. So we've solved question A. Now we can solve question B, where we have to find the total time of the flight. So total time in question B, total time of the flight equals to delta t plus total t prime, where total t prime is the sum of t1 prime plus t2 prime. So the first component is time needed to reach the maximum, and t2 prime is to land from H maximum. So we already know this time. This one equals to this number, and we just need to find the last component. So H maximum equals to GT2 prime squared over 2. So therefore, T2 prime squared equals to 2H maximum over G square root, or square root of 2 times H maximum divided by 10 meters per second squared. Now let's calculate this number. It equals to 14.9 seconds. Okay, now let's calculate total time of the flight. It equals to 3.17 seconds plus 12.69 seconds plus, actually, here let's write down as 14.93 and then we'll round 14 point, because here it's 14.93 seconds. So now we can calculate this number. It equals to 30.79 seconds, or roughly 30.8 seconds. So that's answer to question B. And now we have to calculate the answer to question C. So total length of the flight equals to L1 plus V1 cosine alpha times T1 prime plus T2 prime, or it equals to L1, which is 297.1 meter plus plus V1, which I already calculated, 175.8 plus 175.8 meters per second times cosine of 46.2 degree, and it's multiplied by 12.6, sorry, 12.69 plus 1493 seconds. Okay, now let's complete this calculation. So it equals to 3,658 meters. So this is the solution of this problem. I hope I helped you. Thank you very much for your attention. Bye.